after having seen the R version of networks and visualization, now you get a bit more nice looking versions of this, which only is visible by having a blank screen with white script on it, which it demonstrates us that there are people who not just start their program, but think about how it looks like. Florian.
Thanks so much. Hello everyone. It will be our pleasure actually to sort of finish this day with some reflections on indeed what visualizations could do for you, given all the complex data you already kind of processed during this week. The program announced us as an input, extended input to networks and to the SpaceTime cube, which is correct. We just want to add sort of one other caption to this input of today, which will be continued tomorrow, and that would be to go beyond one-dimensional portraits of biographical or prosopographic data. So even though we know it's necessary to also focus on different data dimensions, on specific data dimensions, this presentation will be also revolving around the idea that we have to sometimes go beyond one-dimensional visualizations and presentations to get the bigger picture of the complex data we usually have at our fingertips. So just very shortly, why bother to visualize? Because interactive graphical representation can really support, amplify, augment, and accelerate our sense-making and our reasoning with abstract data. We follow a very relaxed anthropological perspective here, so to say, which would be that without tools, the human individual is not very smart or is not very capable to deal with different problems. This is a very widely distributed anthropological perspective that really sees culture and tools as the central criterion for success, if you want so, of the human species. And it is also that visualization is building on this paradigm. It's called framework, for example, for distributed cognition. And it really posits that we need tools of all kinds to really act in a kind of intelligent way. And the framework of distributed cognition really also contends that we need collaboration and tools of different kinds to solve our problems. Visualization then would be in this kind of approach one of the latest appearances on the scene, and it really helps us to deal with abstract data because humans have not evolved, and their perception was not really trained on abstract data, but for example just on visible landscapes and moving parts and images, and so visualization tries to tap into these abilities, these natural abilities, and map abstract data to our screens to utilize our...
I feel excited.
Yes, you are, hopefully. So I was happy to see Georg use this slide at day one. It has all the important ingredients here. I would just slightly rearrange the whole thing. So what we have here is obviously, just wondering if I can move this a bit. Yes. We have some historic figure. So at least I think that was the idea of using the figure of Buddha. Probably just an imaginary guy, but we can imagine this to be a historic figure. And then historians do usually the alphanumeric representation. We are doing since, I don't know, 20, 30 years the digital representation. And the idea was, as it's being shown here, our natural perception isn't really trained to work with abstract data. We are very limited in sense-making with abstract digital data. So Georg kindly already used the SpaceTime cube as one visual device that could be used to make sense of complex data. may I just shortly ask a show of hands who has seen this device already before Georg put it on the screen? Okay. That's good, I think, because then we can at least add a bit of information in the next minutes. We are assuming that there is a kind of progress for insights and for human sense making, but we are also aware, this was also a quote from day one, all models are wrong, some are useful. We hope that visualizations can do a useful job, really help the processing of abstract data. In general, we have here remediation steps from the real life, the historical person until the visual representation. And we want to argue in the end for multimodal interfaces. We don't want to play visualizations against verbalization, but we are convinced somehow you have to have both words to really have also some kind of multimodal stereoscopic view and sense making. All right, a very quick survey. We don't have to start from zero here. May I ask you which visualization tools you are using occasionally, frequently? If you could quickly type some of the most used tools into the chat. Maybe with 2 stars or asterisks, it just means that's your main tool. If you occasionally use them, just type them shortly into the chat so that we see where we are actually starting. Okay, we see already maps as a very abstract method. Maybe you can even add, the tools that you use when you do your visualizations. And then we get here different types from the very basic methods to Gephi for network analysis and Aura, and obviously also Marcella showed us R before and what it can do for network analysis. We have Leaflet as a mapping tool, Google Maps, AntomGIS, so geo information systems. We see also open libraries. Yeah, and we see you are already doing what we are talking about here, so we can also already skip the basics and really move forward. Thanks a lot. Very nice. Some of them will be even introduced in more detail tomorrow. The guiding question of the following slides will be how can we utilize the power of visual analytic technologies for digital historians. And the idea is by learning continually about them, both conceptually, which would be the agenda of today, and practically, which will basically start tomorrow. For further reading, if you're interested, we put all the ideas, which we give you a short overview, also into various papers that are openly available. And we will start from this kind of mantra on our side that would be one view is not enough, especially when you have complex data. Right? It will be our working hypothesis that as prosopographers and biographers we have frequently to deal with complex stuff. So we just introduce here a very simple sign. The C on this seal stands for something behind this seal is complex. And we would contend prosopographic data definitely checks this box. So when the question is how do we actually analyze complex data, then we can start from most different perspectives. I just made use here of something that Maximilian Kaiser, a colleague here from the ACDH, just published recently on Twitter. It's just, I think, network visualization of APIS subsection. Marcella showed us how to use network visualization for analyzing prosopographic data. So we have already seen the added value, but what we want to add here is you can also have a locked-in phenomenon, sort of, when you just focus on one specific method, one single data dimension, in this case the relational data aspects, because oftentimes our complex phenomena have some relational aspects or characteristics, but that's not all. So there is a very nice paper from Mushan Seraviv. If everything is a network, nothing is a network, so we can also overdo with network visualization. And there is a very nice, venerable metaphor for complex stuff, which would be the elephant. And if you don't have perfect sight, then you can just start to grasp parts of this complex phenomenon from different sides, and no one gets the bigger picture. Right? So when we just stick to networks, that might be the risk or the imminent danger, that we don't see the other aspects that we have within our prosopographic data. We just see networks, and we want to point you to different other options that are still available aside from relations and connections of data. So, could we frame this? Oftentimes, our subject matters are complex, meaning they are somehow connected, but also they are geographically embedded, somehow hierarchically nested, chronologically ordered, categorized, causally interrelated. They are oftentimes also contested, and they are consistently or very often dynamic or evolving over time. In this case, we should sort of consider this mantra that one visualization method is not enough, but we have to draw together multiple means of visualization. And we have to very selectively make use of the whole repository of visualization methods that is already available. So to quickly recap, biographies often start with some figure, let's say a white imperialistic dude here, and someone takes a picture of him and just writes the biography. And you used already this week to extract information from natural language sources so that we really can just summarize. Biographical data is multidimensional. You have individual names in it, you have geographic names in it, you have categorical information in it, relational info, you have temporal info that, let's say, are just the basis. These are all in our data sets, and it's just usually not enough to focus on only one dimension if you want to get a bigger picture or a sort of comprehensive view. Right, and then we can also keep in mind that individual data sets are already complex, and it gets even more complex when we aggregate them into prosopographical selections or into whole corpora. For example, the APIS project contains, I think, 20,000 biographies, or the dictionary does so. And on this level, we definitely have advanced level of complexity. So it will be also necessary to tap into multiple visualization methods. And then sometimes it would be interesting to have distant reading tools, and sometimes you want to zoom in and have close reading support. And I think, aside from the integrated packages like the things Marcella showed us before, it might be good here to step a bit back and have a look at what is available in general, even though we have no integrated working environment until now that would provide us with the perfect platform to analyze data visually from data acquisition to communication. Okay, so one other recap slide would be this. Our natural language data is oftentimes too complex, so natural language processing helps us with producing and providing databases. And now we first see digital data allows us really to have multiple perspectives. The life of the individuals has already been complex, so we also should have complex enough interfaces. And usually, at this side here in the middle, we work with interfaces with multiple views. We combine, for example, maps and timelines and networks and other options. And we hope that this would allow us to also achieve a mental multi-perspective representation, and that we are then able to integrate different perspectives Yeah, and it would be also possible to at least think of this law of requisite variety, which means only complexity can kill complexity, or complexity can absorb complexity. So that would be our argument this evening, that also our visualization tools shouldn't be too simple. Okay, what is available on the visualization side? I will quickly switch to this catalog. I'm not sure if you've seen it. It's openly available as the database catalog. And if you just want to have a quick overview of what is available aside from networks or maps, or the things you already know, this is a really nice site that allows you to just see some of the most relevant contemporary methods for visualization, which have all different strengths and also limitations. You can click on all of them, obviously, and get a close-up here, where you see how the chart and the diagram of the visualization works. Anatomy. And what are similar charts. And what is very nice, at the end of each diagram, you see also the tools that you can use to generate them for yourself. So this is a kind of encyclopedic approach that is really interactive. It's linked to the tools you can continue to use. And I think it's one of the most relevant sources if you want to dig deeper what would be available also for your yeah, these sites are also interesting because there is a kind of basic insight in visualization research that no visualization method alone can do the whole job. And giving you even just the best insights. Here is just another site. You will find the links all in the slides, which is called From Data to This. And it is specifically tailored to lead you from the data you have. If you're not sure which visualization waits for you, you can just here follow the approaches. So for example, if you have something geographic, then these sites show you what would be possible. And if you just want to know more, you dive in, and you also see here the tools that wait for you in the end to really make, for example, visual sense out of your abstract conceptual data. Okay, so this gave you a short hint that really different options would be available aside from the well-established ones like networks, like maps. And Marian Dirk, a colleague of ours, has coined this with a paper titled "One View is Not Enough." Let's just memorize this, and then we arrive at multiple views, which help us to sort of avoid misinterpretation or short-sighted insights. If we have multiple views, we can just combine the strengths of different perspectives. There has been also a discussion in the humanities recently where this principle has been called generous interfaces or triangulation, plurality, parallax. And yeah, advanced interface design is usually using multiple perspectives just to avoid these misrepresentations that might emerge when we work with just single views. Okay, so what would be some of the most relevant multiple views with regard to biography data? Obviously, timelines are frequently used to just inspect the chronological order of things. But then we can easily also have a look at spatial aspects, at network aspects, or categorical aspects. I also want to quickly show a nice interface that is looking at philosophers. For example, it starts here looking just like an action painting, but when you hover here, it's done by Marian Dirk, you see these are philosophers, and you can then start to explore. And then you see just on demand, you get the connections between this group of people. You just see who has cited whom. And here the principle of multiple views is that you can switch from this network layout, works in a force-directed fashion. And here you can switch, for example, to a timeline view. So now we have to find Nietzsche again. And so even though force-directed layouts are nice, sometimes we need a chronological layout. This interface provides with both. You can switch between this historian perspective or the structural perspective. And you have seamless transitions between them. Maybe.
What's the link?
It's called edge maps. You can see it here in the upper left corner. You also find it in the slides. They are already online. GitLab repo. Oh, good. But if you just search for edge maps and Marian Dirk, you would find the link. And yeah, it's a tailor-made interface, but it could be also very interesting, I think, for quite some prosopographic data sets that we have. Another interface which I like a lot is this Pantheon interface. It's way too complex to show you here in the short period of time. So you would be just encouraged and invited to explore it for yourself. What you get here, for example, is just to look at the cultural heroes of each nation you're interested in. We pre-selected Austria, and then they just looked at data sets of famous people and of people that are mentioned in the Wikipedia in multiple languages. Now you can do that for every country, and you get a categorical tree map here that shows you for which country, for which type of person the country is famous. Tree maps are a quick and effective solution to give you some insights what is in a complex taxonomic space. So interestingly, for example, you can wonder why is Austria so famous for its politicians. And if you hover here with your mouse, you see there is one person that is really in every Wikipedia language version at the very top, and it contributes to us being famous for politicians. But you also see, you can filter here, for example, the time. And the tree map is updated for you. And then, interestingly, just because of the data, if you move forward from 1950 to 2000, we get famous for sports people because all the historic personalities obviously vanish out of the data set and so on. As I mentioned, it's too complex. Unfortunately, we have to switch back and just encourage you to follow these beautiful interactive interfaces on occasion. Our question here would be how to integrate these different perspectives. They are nice to have, they are helpful and valuable. And so the rest of the presentation will be focused on, let's say, our main research interest during the last 3 years, which would be, can we also have a more integrated environment to sort of better make sense with these different perspectives. Again, it would be the aim to overcome this sort of schizo state where we have very different views, and we want to see the bigger picture. So we really want to see the prosopographic data set from multiple perspectives. And yeah, we call what we need for this coherence techniques. So we need techniques that somehow bring these different views together. Right, there would be an interesting theoretical discussion. We can just skip this one and say, if you're interested in different techniques, how to connect your map with the network and the timeline and so on, you can follow these links that we put in there. And we want to just showcase one system, a visualization system that we developed during the last 4 years in the so-called Polycube project. It combines different of these techniques in a way that hopefully helps you to really deal with multidimensional data in a coherent way. Right, the name is polycubism, and this comes from the device that Georg quickly showed you at the very first day. The so-called SpaceTime cube combines timelines, which you all know, geographic maps, which you are very well familiar with, and it does so in an orthogonal fashion. So you put the map on a table and use the third dimension for the timeline, and certainly you have a three-dimensional cubic structure. And usually time moves upward, so that you can say now you can also visualize dynamics, movements, different dynamic phenomena in space and time. This is very interesting because it's freely scalable. You can start from a very selected spatial perspective and scale up to the whole world map. And you can do the same with the timeline. So you can just choose to capture a few minutes and you can scale it up basically. Yeah, whatever world history offers us. Close to 5 billion years for at least our planet. We did a joint project and case studies with our colleagues here from ACDH and the ATMOS project, where we just said, okay, let's try to extract some data points from biographies and make them visible with this SpaceTime cube. So you would be able to also follow our 9 selected biographies, Matthias and Maximilian and Christine Kuba supported us with this, and we were able then to really, for example, take the biography of an adventurer. He's Ignatius Trebitsch Lincoln. He was quite a unique Austrian character. You can see the simplest way to describe him is adventurer, but he was also a member of parliament, he was a conman, he was a spy for Germany, he was a Buddhist monk, and quite something else. And he was quite frequently having encounters with law enforcement. So here, this pink line, unfortunately I can't show you the 3-dimensional version right now. But you can imagine this to be a 3-dimensional analytics environment where you can rotate and zoom all this. You see at the bottom the world map, and then you read it from top to bottom. And, the events that we have in a natural language could be translated into events in space-time. And you see how he started to jump between Europe and America, and then ended his life basically in Shanghai, because there was no other place where he was safe from law enforcement. And when this was one of the most active biographies, we also had to look at the chance then to compare these biographies with other trajectories. Now you see it gets interesting because every human being produces one of these lines in space and time. You did so too. We probably don't have the data to prove it, but you are actually tracing yourself if you want so. Frequently, some companies do have these lines of yours. The nice thing here is this software is also used in law enforcement. We sort of hijack it and use it for historical research. Right? These curves are very expressive. You can really use the data that you have on a spatial temporal scale. And you can also combine individual curves, which we did here. For example, you see like a pair of siblings, Vienna artists, Rudolf and Josefina Svoboda, classical painters, but they had sort of diverging career paths. So while Josephine was able to go to the court of Queen Victoria and then had exhibitions in Chicago, her brother was having the career into the other sort of direction of the earth. And this also already points you to the potential of this method to also visualize groups, networks, and movement of prosopographical entities. Yeah. There is a new kind of pattern language in this approach that we think of as very fascinating. For example, your eye is able to just identify clusters and interesting collective movement patterns. You don't even have to know all the numbers then behind it. Your perceptual system, your visual system is very quick to really identify what is happening. And if you train it a bit with these visuals, quickly will learn to read this new visualization language. Yeah, there is also some need for curation, but I will skip above this and we'll shortly talk about the problem that we have when we, for example, try to really make sense out of thinkers. For example, Immanuel Kant, even though he's a quite famous historical figure, wouldn't produce an interesting space-time curve because he always stayed in Königsberg, Leningrad, where he lived, and he never left his village. So in this case, we thought of we have to multiply again our views and try to have a look at, for example, what did this guy do in kind of correspondences, in kind of international relations, and in which topic areas was he or she. So what we tried to implement then during the last years was a system that allows you to really do that and to visualize, for example, in our case, cultural collections in different these perspectives. I'll just give you a quick look what a network would look like in such a space-time cube. We have again slices of the networks developing over time. And then you can again read it, for example, that we all spend time in different networks. And this visualization method offers you to really have a structural and a temporal look at the same time. Another thing that we tried to visualize was the movement of persons or individuals through topical space. Because even if you're a philosopher and you're permanently at home, you read a lot, and Immanuel Kant definitely did so, and then you can visualize something like this. That, for example, books get published in different areas over time, and then your reading history also becomes kind of space-time trajectory. Wherever you move, you produce a sort of expressive curve that could be analyzed later on. The final option that is quite interesting is we can also follow collectives. If we just visualize sets, then we can say, okay, also groups develop over time, and either they grow over time, and maybe even split or build subgroups, or they merge and get simpler, contract, and finally decline. So the whole point here is this framework, even though we don't have the time to really introduce you to all the details, is very expressive. It uses flat visualization methods plus time, the third dimension. And whatever you throw into it, if you have the data, it produces very accessible, expressive visual representations. Yeah, as a warning, we are not done with this. We tried already to submit a development project during the last 2 years already. Had our latest disappointment quite recently. Still, it's our plan to actually adapt this framework also for biopractical data and to really develop a tailor-made analytics environment. What we do have still is one showcase for you. If I will present it to you as a closing impression, which took made use of cultural collection.
I will try to keep it short because time is already quite late. So what we did is we worked together with some technicians from the Technical University in Vienna, and we did work with a data set by Charles Weaver Cushman. If you haven't heard of him, it's not a problem because it's not that famous. But what he did was he took quite a lot of amateur photographs, and there is a collection of his photographs openly available, and that was the data we built on our prototype. And you have got a short introduction to his biography on the website from the collection. Where you can see the photographs are not that impressive, but yeah. What was interesting is in his biography you will find some information that he was married. So you see here him and his wife, Jean Cashman. And when we tried to visualize his biography in geotime, we found that there are quite some gaps in his biography. And we didn't know what happened there. So what was said in his biography was that he was not employed and had no permanent residence. So, what was happening in here? And so we decided to look at the pictures and maybe try to find out what's happening in here. And ask the question, how can we complement the expert information we have in the biography with some information we gather in other data in this kind of pictures he collected. And also we found some book on his work, and in this book there was some more information on his biography. And in this book we somehow figured out there was some event in his life. So his wife shot him and herself, and both survived. So it was really interesting to see that. But the question was, how did this influence also his photographs and collection we have got here? And as we say, we put that into three perspectives. So we had a geotemporal perspective, a categorical temporal perspective, and also a relational temporal perspective. And when you look at the geocodes, you can see here the space-time cube, where each of these dots is one of his pictures. And you can see here a very stable period. So that was the period after his shooting, which is here. And here in this time he was quite stable, as you can see. But before and after that he was really traveling quite a lot around. And this period of no movement seems to be explained by the shooting, because his wife was afterwards in a sanatorium, and so he had to stay there so that he could keep the connection. And only after she left the sanatorium, they started to travel around again, and also moved to the West Coast. If you look at the categorical visualization, you can see how the kinds of pictures he took changed over time. So, for example, you see here that each category has some kind of shape, and you can see in what kind of periods he took more or less photographs. If you look, for example, on these two areas, there seemed to be this incident also on the kinds of photographs he took. So in these areas, in these times, he didn't take as many as different photographs than before and afterwards. And also, you can see if you look at the combination of the two cubes, that in the times where he didn't travel around but stayed more local in Chicago, there were less landscape photographs, so he wasn't traveling out of Chicago, and that's why he didn't take any scenic pictures here. So you can also have these relations between the categorical and the geographical data that it shows here. Let's see. So if you want to see the cube, that's the prototype. And you can just rotate the cubes so that you can see all the hidden pictures, which is very important if you've got a three-dimensional representation. If you say it's too dense, you can also switch off one of the views so that you have got the reduced information. You can filter in here by time and say you're only interested in a specific period, so that it also helps you to just keep a better overview. You can also change the view if you say you're not in favor of the 3D view. There's also a 2D view that will allow you to just see that one in two-dimensional state where the time is color-coded. So the yellow dots are the ones that are the recent pictures, and the dark ones are the older ones. And you can also explore these on the close reading level. So you will get the picture on the left, some description is also related objects in here. So you could also have this text that you could click into the text and get some information on the biographies there. Yeah, so that's just a short shot. We can put the link to the prototype maybe in this chat afterwards. You can just, okay, but you can just explore it there yourself and see how it goes. So as some takeaways from today, biographical data are complex, they are multidimensional, they are consistently time-oriented, you know that. But to represent them, it's not enough to have only one visualization method, but you need a plurality of them. And then you will get a more complete and more holistic picture on the biographies today. You have to support the integration of information, so it's not enough to just get one view, another view, and put them side by side, but you have to relate them, you have to connect them, and there are some techniques that have been introduced on that one slide that help you to reconnect the different visualizations. And yeah, we are still working to adapt that framework, but we think it's a good way to go where we can really show a bigger picture of prosopography. And that's it for today. Thank you very much. And if there are any questions, we know it's late.